So this is a paper 2-star question, which is about the operation of a hard disk. So describe the operation of a hard disk, including how data is stored and retrieved, 6 marks. So it's quite a commonish sort of question, I guess, from GCSE, asking you to describe a piece of hardware and how it operates as a piece of secondary storage. So what I've tried to do here is write a model answer. So the hard disk comprises multiple disk platters. So each disk has a spindle, or each drive has a spindle, and on that are a number of platters, which obviously these are all supposed to be the same size, and they are sealed inside a unit. And so each of these platters is on a spindle, and imagine the spindle is in the middle, the disks around the outside. It spins, each disk spins around on the spindle. So they're on a single spindle, and each platter has a read-write head that moves in and out across the disk surface. So across the disk surface, the read-write head often looks like this sort of arrangement with a read-write head on the end, and there's one of those for each platter, so for each side of each platter. So you've got a read-write head for each platter, each side, and they move just in and out across the disk surface, so in or out. So if we just make that a bit more round, that might be useful. So our disks are, there's our spindle, so they have tracks inside. So on the disk, each platter has a track. They're divided up into sectors like this. So a sector then has a block of data, and that block can be read by the read-write head when it spins underneath the read-write head. When the disk spins around, the read-write head's in the correct position for the track. It reads the data. So these read-write heads, they're very close to the surface, and each platter's got concentric tracks. So I said this concentric idea, one inside another. It's concentric tracks. That's what concentric means. So they're further divided into sectors, and each sector has got blocks. So data is stored by changing the magnetic polarity of microscopic sections of the disk. So the polarity in a tiny section could be north-south or south-north, and we can change those using the read-write head. And of course, that could be representative of 1 and 0 binary numbers. So I've said here that the disk surface is coated in a metal oxide material. So it is coated so that we can, it's magnetizable, so we can magnetize it. So I've said here one polarity is 1, the other polarity is 0. So you've got to say this. If you want to get the mark in this, you've got to say something to do with the polarity and the different polarities representing binary 1 and binary 0. It's not enough to say data stored as 0s and 1s, because it isn't. It's stored as magnetic charges. So it says we need to say how the data is stored and retrieved. So we've talked a little bit about that, but when the disk is read, it spins at a high speed under the read-write head, and a whole block of data is read at one time. These are called block devices. Block device. So the whole block's read. Even if you only want a very tiny bit of the data that's on that whole block, it's going to read the whole block and use the data it needs, read it into RAM, use the data it needs, and then the data it just doesn't need to bother about, because when it reads it, it's not removing it from the disk, it's just taking a copy of it and putting it into RAM. So the data is transferred to the main memory via cable. So you're going to have some kind of cable and drive electronics that will work with the drive itself and do addressing. So addressing, a block of data is addressed or identified. The address is the platter number, so which number disk it could be. These could be numbered 0, 1, 2, 3 as platters. The side, so side 1 and side 2, so 0, 1, and the sector, which is the wedge-shaped bit, and the block to read. So once we've got that address, we can spin the disk up, get the read-write head into the right place. When it passes under, it reads the data, and we are on the way to sending that data then back to RAM. So the drive electronics manage the addresses, and they also provide a buffer for the data between the disk and the RAM. So that last concept, bit more of an A-level idea, but doesn't hurt. It's absolutely correct. So we're going to write that data into RAM, and then the processor will access it from RAM. So this is the principle of operation of a hard disk drive, and including the data. And there's lots of marks here that we've got, far more than 6, so we've gained all of our 6 marks from this. So if you only remember that it's using magnetic polarity, north, south, south, north, to store binary, and that there are a number of platters and that it spins around, then you're going to get some marks for all of that. So it might be worth you trying to remember the idea of magnetic, because hard disk is a magnetic store. So what do we know about magnetic? Well, we know that it has polarity. So if we can describe the polarity, then we can describe 2 states, and noughts and ones from that perspective. Because it's a disk, it needs to spin so that we can find the right bit on the disk. And we've got this idea of the read-write head. So if we can't remember that it's a read-write head, then it doesn't matter. At the end of the day, we could say that it's read by an arm, if you like, that moves in and out across. You'll probably still get the points for that. So that is model answer for a principle of operation of a hard disk.